Hi all, let's continue our discussion on the dynamic force analysis of slider crank mechanism. So in dynamic force analysis, we will be considering the effect of inertia forces as well as inertia couples. For that, we have evaluated the magnitudes of acceleration of the piston as well as the angular acceleration of the connecting rod in the previous video. So based on that, in this dynamic analysis, we will be specifically discussing about some terms that you can see here. What is piston effort, force acting along the connecting rod, crank effort, turning moment on the crankshaft. All of these terms will be discussed. And for this analysis, we will be taking the inertia effect of only the piston. That means this analysis is based on this assumption that the inertia effect or the entire weight associated things of this connecting rod will be neglected, and all the dynamic force analysis will be done by considering the effect of this reciprocating mass only. So for this analysis, we will be discussing these terms one by one. So first one is piston effort. Piston effort is represented by capital F, and it is simply the net force acting on the piston. So here you are having the piston. This piston is coming within the cylinder, so it is subjected to gas on both sides, the gas within the cylinder and also with respect to the atmosphere. Let the pressure inside the cylinder be P1 and the effective area inside is A1, and pressure P2 and A2 on the other side. So this will be creating some force on the piston in this direction, and this will be creating some force in this direction. So net force due to this gas pressures, I can call this as FP. FP means force due to the gas pressure, and that is equal to P1A1 minus P2A2, and this net force is acting along the right direction. And there is another force because we are considering the inertia effect of this piston. So this piston will be having some mass, and when the connecting rod is rotating in this direction clockwise, this will be having some acceleration towards right. So because of this accelerating mass, there will be some inertia force which is acting in a direction opposite to the acceleration, and I can call it as Fi, which is equal to mass into acceleration, or minus ma since it is opposite. And the expression for acceleration you have already evaluated from the previous discussion or from the previous lecture, which is equal to r omega square into cos theta plus cos 2 theta divided by n. So now we are having the force due to the gas pressure, that is this force, and the force due to this inertia force, and resultant of these two forces will be known as piston effort. So the piston effort F you can calculate like this. So piston effort F is equal to the force due to gas pressure which is acting towards right, I will be taking as positive, and the inertia force which is acting towards left, and I will be taking it as minus Fi, and this is equal to this P1A1 minus P2A2 minus of this mass into acceleration, which is mass into r omega square into cos theta plus cos 2 theta divided by n. So this is known as the piston effort, where this F is known as the piston effort. That means the net force that is acting on this piston. So now we are having the expression for the piston effort. Using this one, we will be defining the next terms. And one more point to note, in the case of vertical slider crank mechanism, there will be one more component, that is, if it is vertical, then the arrangement will be coming like this. This is the connecting rod and this is the crank. So here the weight of this one will also be considered along with this piston effort. But now we are having only this much components for the shown arrangement or shown slider crank mechanism. So the next term that we are going to discuss is the force which is acting along the connecting rod, and I will be calling it as FC. So if you are saying here, this is the force, the piston effort, net force acting on the piston, and if you are analyzing the free body diagram of this piston here, force will be acting from the ground, and that is known as normal force or reaction Fn, and there will be also another force which is acting along this connecting rod. And if you are seeing that force is directed along the connecting rod, and I can mark it in this direction, and its arrowhead for the equilibrium, the arrowhead will be coming like this, so that this will be having two components, one component in this direction and the other component in this direction. And this force acting along the connecting rod is represented by Fc, and this angle is phi. Then this will be equal to Fc cos phi, and this one will be equal to Fc sin phi. So for the equilibrium, you can write the piston effort F is equal to the force along the connecting rod Fc into cos phi. So Fc expression you will be getting as F divided by cos phi. This is an important expression. So the force acting along the connecting rod with respect to the piston effort is F divided by cos phi. In a similar way, you can evaluate the normal reaction, or it is also known as the thrust on the sides of cylinder. So thrust on the sides of cylinder, which is equal to Fc sin phi. So this will also be asked in some questions. So anyway, we will be taking this expression for further discussion. So this Fc equal to F divided by cos phi, where F is the net piston effort. So next one is the crank effort. Crank effort is the net effort or force applied at the crank pin. So crank pin is located here, and we can see from this one. So this is the force along the connecting rod Fc, and that will be acting at the other end in this direction. So this Fc can be resolved into two components, one which is acting along the in this direction, which is perpendicular to the crank, and one along this crank. So the component which is perpendicular to the crank, that means this Ft is known as crank effort. So here for resolving this Fc to Ft and Fr, we require this angle. So this angle is actually phi, then this angle will be equal to 180 minus of theta plus phi. Then this angle, that is the angle between this blue and red Fr, it will be becoming theta plus phi. The angle between the two red line is 90 degree, because Ft and Fr are at 90 degree. The crank effort Ft will be equal to Fc into sine of theta plus phi, and the Fr will be becoming Fc into cos of theta plus phi. This crank effort is actually this Ft, and this Fr is one which is acting along the crank, or which is acting in the bearings of the crankshaft. So this Fr is known as the thrust on the bearings. So this is known as thrust on the bearings. From here, actually we require this expression, which is the crank effort, which is Fc into sine of theta plus phi. So you can rewrite that as the Ft, crank effort, is equal to Fc is actually the force acting along the connecting rod. Just before we have written it in terms of the piston effort, which is equal to F divided by cos phi into the sine of theta plus phi. So here I have rewritten this Fc in terms of F. So now this will be becoming, the crank effort will be becoming in terms of the net piston effort. So Ft is equal to F divided by cos phi into sine of theta plus phi. And the last one is turning moment on the crankshaft. So turning moment means the torque which is created about the crankshaft, and the component of this Fc, that is the crank effort, which is acting in a direction perpendicular to the crank, will be creating a moment about this crankshaft, and that will be equal to this force into the perpendicular distance, that is the length of the crank. So you can evaluate this torque or turning moment on the crankshaft as the product of Ft into R. This Ft is equal to Fc into sine of theta plus phi into R, and this Fc in terms of piston effort is F divided by cos phi into sine of theta plus phi into R. So here you can expand this sine of theta plus phi in the form of sine of A plus B. Then this will be becoming sine theta cos phi plus cos theta sine phi. And here one cos phi is coming in the denominator, and here you are having one cos phi. So this will be getting cancelled. Then our torque will be becoming, this torque is equal to F into R into sine theta plus cos theta into sine phi divided by cos phi. In this form you will be getting, and you can express this cos phi in terms of sin phi, which is equal to square root of 1 minus sin square phi. And again you can express the sin phi in terms of theta. So from the previous class, if this is phi, then you are having this sin phi is equal to sin theta divided by L by R, and we'll be calling the ratio of L by R as n. Then this is equal to sin theta divided by n. So the expressions or substitution for this sin phi can be given. So this will be becoming sin theta by n, and again for this one also you can give substitution. And finally you will be getting the expression for the turning moment on the crankshaft or the torque, and that will be becoming F into R into sin theta plus sin 2 theta divided by 2 into square root of n square minus sin square theta. So this is the final expression for the turning moment or torque which is acting on the crankshaft. This is all about the dynamic force analysis of the slider crank mechanism by neglecting the inertia effect of the connecting rod. So hope you understood. This topic is very important, and we will be discussing problems on this one in the next coming video.